Hi students, let us learn the next chapter of class 10, that is metals and non-metals. So we'll start with the introduction. So as we all know, the periodic table consists of 118 elements, out of which 93 are metals. So the gray color elements that you can see, they're all metals. The remaining would be non-metals and metalloids. So today let us learn a few physical properties of metals. The first one is malleability. So this property is unique only for metals, and it states that the metals can be beaten into thin sheets. So the most malleable metal is gold, silver, and lead. So as we all know, when we talk about Rutherford's alpha scattering experiment, which paved way for the discovery of nucleus, Rutherford made use of gold foil, and gold foil was so thin that only 1,000 atoms were present in that gold foil. So it is, you can consider that how small or how thin the sheet of gold would have been. Okay, so hence gold is the most malleable metal. Now the second property coming is ductility, the property of metals by which they can be drawn into thin sheets. So again, the most ductile would be gold, silver, and copper. Then third property is sonorous. Metals can produce ringing sounds. We all know the bells in temples, and also many instruments also have which are made up of metals, are they produce unique sound. The next property is luster. Metals have a shiny appearance on their surface. So now we will understand why metals mainly show these properties of malleability and ductility. So all this reason is because of metallic bond. So let me just give you a brief introduction of about metallic bond. So if I consider this block to be a surface of metal, okay. So let's take consider some iron, piece of iron, and this is the surface of the metal. So the metallic surface is such that we all know, when we talk about the atom, so we know there is a nucleus in the center, that's that makes up the core, and we have the electrons revolving around the, so this is the nucleus. If I say this as the nucleus, and these are the electrons which are revolving around the nucleus. So here also the same thing I can express. All these plus would be the nucleus, okay, and the electrons which are in the bond, sorry, which are in the valence or the valence orbit, okay, I'm representing it as minus. So now we also know that when you talk about the properties of metals, okay, they are electropositive in nature, means they tend to donate electrons easily. So now these electrons, okay, which are in the valence shell, they can easily be removed because they are electropositive. They can be easily ionized. So whenever electrons are ionized, we know that basic nature of physics, or um, the nature of chemistry also, we can consider like positives, okay, or sorry, like poles repel and unlikes attract. So here there's a unlike, that is, we have nucleus and then we have electrons, so obviously there'll be some kind of attraction between them. So electrons, what they do is they easily move from one, okay, positive charge to another positive charge. So like this, electrons keep on moving from one nucleus to another nucleus, and this creates um, unidirectional motion. Okay, so that's why metallic bonds or metals are so flexible in nature. They can easily be beaten into sheets, or they can easily be drawn into um, thin wires, mainly because of this property of metals, that is, they are primarily having metallic bond. So in metallic bond, electrons are easily moving from or delocalized from one nucleus to another. Okay, so because of that, what happens is the atoms can easily slide on one another. Okay, atoms can easily slide on one another, and because of this, um, metals can easily be given any shape. Okay, they can be beaten into sheets or they can also be drawn into wires. So that is the malleability and ductility. So this is not there in the syllabus, but it's just for your basic understanding. Similarly, when you talk about luster also, okay, when you talk about the nature of luster, see non-metals, if you take carbon or if you talk about sulfur, they're not luster, isn't it? They're very dull um, in look. But when we talk about metals, they're very shiny. See, for example, talk about gold. It's yellow and it's so bright. It's always shining, right? Or when we talk about silver, right? It is also a metallic color, and it is also very shiny. So most of the metals are have luster in them. That's they're always having a shiny appearance. So now this again reason would be again talking about the nature of electrons in metals. So as they can easily donate the electrons. Okay, so let's say these are the electrons on the surface of the metal. So whenever light falls on these metallic piece, what happens? Electrons can easily reflect. Okay, electrons can easily be knocked out from their surface. So because they're easily knocked out from their surface, for us it looks like there is something shiny. Okay, so it's all based on the movement of electron and also the radiation falling on it. Okay, so as the radiation falls on the metallic piece, the electrons gets knocked out, and because of that we feel like it is having a beautiful luster in them. So all these nature of our properties are only basic understanding is because of nature of the metallic bond. Okay, so now next let us go with ahead with some more physical properties. They are good conductors of heat and electricity. Metals are usually metallic in color, as I already told you, except uh, copper and gold. Gold is yellowish, whereas copper is dark brown. Metals are solids in nature. See, most of the metals are solid in nature, and there are few exceptions like mercury, which is a liquid. Okay, so with this, we conclude today's video. In the next video, I will be talking more about properties of non-metals. Okay, thank you.